Bismillahirrahmanirrahim. Today we are starting section 2.5, that is roots of quadratic equations for additional mathematics course. Here we have a discriminant term. This is quadratic formula. This square root is at b square minus 4 is a discriminant. It has a very important significance for quadratic equation solutions of a quadratic equation. So whenever this is greater than 0, we have two distinct roots. When it equals to 0, then we have two equal roots, and when this is less than 0, we have no solution, no real solution. So we can see from here, this is 0. When this is 0, we have two equal roots. When this is less than 0, there is no real roots, and when this is greater than 0, we have two distinct roots. So we call it discriminant. Discriminants is b square minus 4ac. So we will learn 2.5 here, and this is very important. Two distinct roots, two real equal roots, and less than zero real roots, means some imaginary roots will be available but no real roots. We have already learned all these things in our previous sections, so these are important. So we'll start from exercise 2.5. So 2.5, we will solve these two distinct roots, two equal roots, and no roots. We will solve this to obtain these two conditions. So we have to find the discriminants of these problems. So the first one, compare it with a b c. We have this b square minus 4ac. So this is 0, two equal roots. It's a perfect square. We have two distinct roots. We have two distinct real, no distinct roots because discriminant is negative. Greater than 0, distinct real roots. Equal roots because discriminant is 0. G, no real roots, distinct roots. Now problem number 2. Find the value of k for which this has two equal roots. We have to find a value. Which gives two equal roots. So this is, we go for the discriminant. This is b square minus 4 ac. ac is equal to 0. So k is discriminant is equal to 0. So this is 0. So this is this is this. So k is equal to plus 6 or minus 6, which give two equal roots. So in place of this minus 6, this becomes x minus 3 whole square, or for x plus 6, this becomes x plus 3 whole square. We can check it. For the third problem, find the value of k for this has two distinct equal roots. Two distinct roots. Again discriminant, and we'll find the value of k, which will give discriminant roots. Value of k for which this discriminant is this, and if k is less than half, then this will give a distinct roots. At k is equals to half, this gives a equal roots. So k is equal to half, this becomes 16 equals to 0. So for at half value, this gives you two equal roots. For less than half, it gives two distinct roots. For greater than half, it will give you very different conditions. Okay. So value of k for which this is equals to has no real roots. Find the value for problem number 4. Find the value of which no real roots, means discriminant should be less than 0. So we have to find the value of k in such a way that it gives no real roots. So k is greater than 1 upon 3. If we take value of k is greater than 1 upon 3, we will get no roots, no real roots. For question number 5, find the value of k for which this has 2 equal roots. So we have to find the discriminant gives a discriminant equal to 0. If we put the discriminant equals to 0, and at that condition we can get the value of k. So for problem number 5, we have to get the value from these conditions. We have to place it in a discriminant. This is b square minus 4a, and this is minus 2k is our c value here. So k square minus 4k plus 1 minus 2, by simplifying minus plus 2 8 k plus 1, and by simplifying further we get 8k square plus 8k is equal to this. So 9k square 8k, k may be taken out as a common, so this equals this. So k is equal to 0. Either this is equals to 0 or this equals to 0. So k is equal to 0 and k is equal to 9, minus 9. So two conditions. So if we take k is equal to 0, we have 2 equal roots. If k equals to minus 8 upon 9, we get 2 equal roots. For problem number 6, find the value of k for which this has 2 distinct roots. So we have to find a discriminant which is greater than 0. This is for distinct roots. So this is b square minus 4a and c. So this is the condition. We actually solve it. Take out 4 as a common and eliminated. This comes this. So this is minus 3 by 2, 1.5. So if k is greater than 1.5, then this quadratic equation will give distinct root. For problem 7, problem 8, problem 9. So let's go for problem number 10. For problem 9. Problem number 9. Let's go for problem number 9. For find the value of k for which this has 2 equal roots. For problem number 9. problem number 9. For two equal roots, so we have this condition, so we have obtained this. For discriminant, so this is b square minus 4ac equals to 0. We have obtained this solution, and from here we have this. So k is equal to 4 or k is equal to 1. If we have either k is equal to 1 or k is equal to 4, we have two equal roots. Similarly, for problem number 10, we have two distinct real roots. For distinct real root, we have to get the condition value of k gives real distinct root. So this is b square minus 4a and c is minus 2k. This condition is this. So k square minus 4k plus 4k, 8 minus 4k plus 8k plus 4k plus 4 is greater than 0. So this is greater than 0. Now for any real values, positive or negative, this k is always for any value, any real value, positive or negative, this gives you greater than 0. So this is problem number 10. Now we will cover 2.6 in the next session.